All right, balanced chemical equation. We're going to go H2SO4, sulfuric acid, reacts with barium hydroxide to make water and barium sulfate. By the way, friends, if you're struggling with these neutralization reactions, don't worry. I'm not going to have you write one on the test. You just have to be able to use it for a titration. You need to balance this. I'll pop a 2 right there. And now I think it's balanced. So this is a 1-to-1 mole ratio of acid to base. I'm going to skip A and B. I think we're all good on those. I'll jump down to C here. Used her data to calculate the molarity of the acid. What did she think the molarity was based on the data she collected? We know that eventually we're going to be calculating molarity, which means we need moles of acid and we need liters of acid. We know liters of acid already, right, because it's in our data table. 12.3 milliliters of acid were reacted, but we need to know how many moles of acid were in that flask, how many moles of acid were in that 12.3 milliliters. Of course, that's how the titration works, right? We add base until all the acid has been neutralized, which is when the pink color is allowed to show. So we need to figure out how many moles of base we have first. So we know based on the readings of the burette, going from 13.05 up to 35.2. So I know that 22.15 milliliters of base were added to the flask. 22.15 milliliters of base were needed in order to react with all of the acid. So we need to know how many moles that is. Luckily, we do know the molarity of our base here. And the molarity is 0.10 molar barium hydroxide. So 0.10 molar. How do I solve for moles? That's right, I can just multiply. So I'll do 0.02215 times 0.1, which gives me my X number of moles, where X is 0.002215 moles of base. Since we said that this was a 1-to-1 mole ratio between the barium hydroxide and the sulfuric acid, I now also know how many moles of acid were present in the flask. And now I can just divide that by the liters of acid that were in the flask, and that should give me the molarity of the acid. In my flask was 12.3 milliliters, so that's 0.0123. I got 0.180 molar. There's my answer. Or rather, Maddie's answer, based on the data that she collected. But if you noticed, she overshot it. Her phenolphthalein went dark pink. And remember, the goal, of course, is to just get pale pink. We want to add just enough of the base to just barely kick the pH over so that we know that we use the minimum amount of base required. She used more base than she should have. All right, so let's think about the effect that's going to have on our answer here. This number here, this number of moles of base, definitely is the actual number of moles of base that went into her flask, right? Because that came from just the milliliters that came out of the burette and the molarity of the base, which she knew what the molarity was. But she's assuming, or her math is assuming at least, that 0.002215 moles of barium hydroxide is also the same number of moles of sulfuric acid that were in the flask to begin with. That's not necessarily the case if you overshoot, right? So technically, there are fewer than 0.002215 moles of acid. Or there were fewer than that in the flask to begin with. Does that make sense? This is kind of hard to explain. Since she overshot it, she put more moles of base than there were moles of acid. That's a better way to say it. She put more moles of base in the flask than there were moles of acid present. If she had got it just right, it would have been that pale pink. But since she overshot it, since it's that dark pink, we know that she actually put more base than acid. She put more base than there was acid. So the real number of moles of acid that were present is something smaller than 0.002215. Let's make up a number and say it's 0.002115. Let's pretend that that's the real. You can see that if we divide that by the 0.0123 liters, this is going to give us not 0.180. Instead, I got 0.1719 or something molar. So we can see that the real concentration, now again, it's probably not that, but it'll be something smaller than what she calculated, right? No matter what number we put here that's smaller than this number, we're going to end up with a molarity that's smaller than 0.180. So lower. The real concentration is lower because she overshot it. Don't worry, there's not a question like that on the test. I thought it was fun. Okay, that's it.